Türkiye döküm sektörünün değerli temsilcileri, yeni bir webinerde beraberiz. Bu yılın son webineri değil, sondan bir önceki webineri. Şimdiye kadar yaptığımız yıl toplam 2023 yılı içerisinde 18 webinar ve 8 seminerle bu yılı verimli bir eğitim yılı olarak tamamlamış olacağız. Bir önceki webinlerimiz enerji konusundaydı. Enerji maliyetlerin düşürülmesiyle ilgili dijital enerji platformu bize sunuş yaptı 21 Kasım'da. Bundan sonraki webinlerimiz 26 Aralık'ta gene aynı konuda. Gene enerji maliyetlerinin bu sefer high pressure die casting'te enerji maliyetlerinin düşürülmesi. Gene dijital enerji yapay zeka destekli bir platform. Bugünkü konuyu ise biraz sonra anlatacağım. Şimdi her zamanki kurallarımız geçerli. Sorularımız aşağıdaki soru kutucuğuna yazılacak ve sunum sonunda ben size bu soruları konuşmacılara soracağım. Oraya ister Türkçe ister İngilizce yazabilirsiniz. Sunum sonunda gene bir memnuniyet anketimiz olacak. O ankete cevap vermenizi istiyoruz. Bu şu açıdan önemli. E, iyi giden ya da kötü giden ne varsa biz görmek ve önceden tedbir almak istiyoruz. Sonradan geç kalmamış olmak için. Şimdi bugünkü konumuz birazcık farklı. Şöyle farklı. Sunumlar İngilizce olacak ama ekranda Türkçe göreceksiniz. Arzu eden arkadaşlarımıza bu Türkçe sunumu daha sonra LMA aracılığıyla paylaşabileceğiz. Ben bu vesileyle e, CURİMBABA firmasının Türkiye temsilcisi LMA MOTİF firmasına teşekkür ederim bu webinere vesile oldukları için. Hepimiz şimdiye kadar sentetik kumlarla ilgileniyorduk. Kum problemlerimiz her zaman çok büyük olduğu için onların çözüm doğrultusunda sürekli arayış içerisindeydik. Bu sefer karşımıza alternatif bir ürün çıktı. Castball, boksit kumu. Boksit kumunun bugün nasıl üretildiğini, ne tür özellikleri olduğunu detaylı olarak dinleyeceğiz uzmanlarından. Bize bugün sunumu yapacak olan firma Brezilya'dan, kendi ana dilleri Portekizce olmasına rağmen İngilizce olarak anlatacaklar. Üç konuşmacımız var. Üç konuşmacımızdan birincisi üretim proseslerini anlatacak. İkincisi şirket tanıtımını yapacak. Üçüncüsü de esas konuşmacımız Elaine Carina Carlini ise Castball hakkında bize detaylı bilgi verecek. Ben sunuşu sözleri kendilerine bırakmazdan önce esas konuşmacı olan Elaine hakkında birkaç cümle söylemek istiyorum. Kendisi bir dökümhane mühendisi ve malzeme mühendisliği konusunda master derecesi var. 20 yıllık döküm tecrübesi var. Hem kendi ülkesinde hem diğer ülkelerde ve değişik büyük dökümhanelerde çalışmış. Bunlardan en büyük Tupi dökümhanesi. O da Brezilya'nın en büyük dökümhanesi. Verimlilik ve kalite geliştirme konularında projelerinde önemli görevler üstlenmiş ama özellikle damarlaşma ve metal penetrasyon konularında o iki konudaki hataların giderilmesi konusunda geniş çalışmaları var. Şu anda kendisi bir araştırmacı olarak çalışıyor ve süreçlerini iyileştirmek isteyen dökümanlar için her zaman yardım etmeye hazır olduğunu bildiriyor. Ben şimdi sözü üretim prosesleri konusunda anlatımda bulmak üzere Sayın Peter Nakajami'ye bırakıyorum. Yes, please. It's now you can start your presentation, Peter. Thank you.
Okay. Good afternoon, everyone. My name is Alexandre Kumai. I work in sales for the group. I'm basically responsible for development of Castball in Europe. So in this presentation, we're going to do a brief introduction about CURİMBABA Group. Then we will talk about the bauxite sand and the manufacturing process. After that, we'll cover Castball sand physical and chemical properties. Then we talk about sand thermal properties. and then durability. We're going to cover also compatibility of Castball with organic and inorganic resins. And in the end, a summary of the potential and limitations of Castball. CURÍMBABA Group is a Brazilian family company. It's in the market for over 60 years, developing premium products and services for foundries, oil and gas, surface treatment, ceramics, refractories, abrasives, and agriculture. We have distributors and representatives all over the world, which enables us to strengthen our production chain and offer more quality and technology in our processes. So you can see in this slide, we have around 14 companies in our group in most different areas. But about the foundry products that we offer in our group, we have a silicon carbide metallurgical grade in a factory in South Africa. We also produce material for blasting. We have developed Sinterblast, Sinterball. It's material, is a media made of bauxite. We have white fused alumina, brown fused alumina. We also have products for investment casting, and we call it microcast. And we also have white fused alumina for this market. And also the fused oxides like the white fused alumina, brown fused alumina, and mullite. In the group CURÍMBABA, we have Elfusa, which is one of the largest aluminum oxide producers in the world. And the topic for this presentation will be Castball, the ceramic sand for foundry. Now, Peter Nakashima, our technical manager, will explain more about the production process of our bauxite sand. Peter, please. Mr. Safe, can you unmute him?
No need to unmute him.
Oh, he is already unmuted. Okay, Peter. One minute.
We hear you quite good.
He says he's unable to speak. I guess his sound is mute.
His microphone should be on. He has already. Is he Peter?
Peter, yes.
Peter. Fikri Bey, Peter'in mikrofonu da açar mıyız? Peter Nakashima.
Yes, correct.
Just a moment. Now it's your microphone is on, Peter.
Okay, guys. So nice to meet you. Good afternoon, everyone. My name is Peter Nakashima. I'm the technical manager at the CURÍMBABA Group. I'm a materials engineer and I have a master's degree in the same area. And I've been working at the CURÍMBABA Group for almost 20 years. And thanks a lot for joining us today. I will present a summary of the production process of the Castball. That is our ceramic sand that we already supply for many countries around the world for the foundry industry. Here we have a simplified flow chart of our process. The production process starts with the raw material, that is the bauxite. The bauxite is a mineral mainly composed of aluminum hydroxide with other contaminants like titanium, silicon, iron oxide, between others. The first step after we receive this bauxite here in our plant is to analyze every lot of raw material, and then we prepare the blends of these bauxites to get the right chemical composition of the final product. So for instance, we have to mix different qualities of this bauxite with different amounts of silicon oxide, different amounts of titanium, iron, aluminum oxide, to get to the final composition of the product. After the raw material is prepared and all analyzed, we start the drying process. Drying is done in this rotary dryers, in which the capacity can go over 1,000 metric tons per day. In this process, we have to reduce the moisture from the bauxite from 25% to less than 5%. After drying, we have to mill the bauxite. So here we use the pendular mills to produce a powder of the bauxite. This powder of bauxite has a particle size of 90%, more than 90% less than 45 microns. So it's a very fine powder that we have to produce here during milling. After milling, we transfer the powder to the pelletizers. Using these pelletizers, we add water and additives to the raw material, and the movement of the vat and the internal tool produces the spheres. So during this process, we make the spherical shape of the Castball, and we also make the primary size of the product. So after pelletizing, we have the sintering process. We have rotary kilns here, where the temperature goes over 1400 Cs to increase the density, reducing the porosity of the spheres, and consequently increasing the mechanical strength of the product. In this stage, we obtain the mineralogical phase of the Castball. After sintering, we have the sieving process that defines the final size distribution of the Castball by using a vibratory set of sieves with different openings to reach the adequate GFN and the adequate size distribution of the product. And after that, we have the packing. During packing, our quality control is responsible for collecting samples from each big bag and run all the analysis for the Castball. For instance, size distribution, GFN, density, pH, ADV, and tensile strength. And it's important to mention that during all the steps of the process, we collect samples to monitor the process. For instance, we monitor the moisture during drying, the size of the powder, the particle distribution of the powder during milling, the size of the spheres during pelletizing, the density during sintering, and so on. And additionally, all these steps are fully automated to guarantee the stability of the process and the quality of the product.
Okay, now our colleague Elaine will do the presentation about the Castball.
Hi. Sorry, my name is Elaine. Mr. Selfie introduced myself, and nice to meet you. Okay, next. Well, Castball sand is based on sinterized bauxite, as Peter mentioned. Therefore, its composition is typical of aluminum silicate with high content of aluminum oxide. The mineralogical composition contains high level of corindon with traces of hematite, manganite, and mullite. In this third table, we can see typical characteristics of Castball sand, such as LOI, humidity, pH, ADV, and bulk density. One of the main characteristics of the Castball sand doesn't contain crystalline silica in its composition. It's very, very important for safety and health. And the high level of the corindon give to us a high thermostability and durability that we are going to see in the next slides. Next. Here we have the size distribution, okay, the particle size distribution. These are the typical particle size distributions curves of the Castball. We can offer the sand in the following DNF: 40, 45, 50, 55, and 65. Another characteristic is the shape of the grains, which is rounded, okay? This type of the shapes in the rounded grain sands provides high permeability, where we can reduce defects associated with trapped gas. And the second advantage is a higher sand flowability, increasing the mold density. The graph shows a comparison of the permeability results of the sands using in foundries. The tests were carried out according to AFS procedures, and only the grains retained between the 40 and 50 meshes were tested. We can see the high permeability of the Castball. Although mullite sand and an alternative sinterized bauxite sand also have rounded grains, the great permeability of Castball is because the size of the grains are very similar at the same mesh. Can you? Yes, thank you. Here we have some results, okay, from the United States, from the university from the United States. Just to confirm, okay, we have here a comparison of two foundry sands, Castball and silica. The particle size distribution curve is the same for both, as you can see. And Castball presented higher permeability when you compare with the silica. Just to confirm about the shape of the grains, the rounded shape give to us a high permeability. Okay, you can change. Here we can see the grain shapes at the different foundries. Castball, a mullite sand, sinterized bauxite, alternative, silica, chromite, and a fused bauxite sand. Okay, silica and chromite sand have a angular shape, and silica presents a sub-rounded shape. The others, ceramic sands as Castball, mullite, and bauxite sands normally presents a rounded shape, grains. Okay, now we're talking about thermal properties. In this graphic, in this slide, we can see a graph that shows Castball thermal spatial behavior in comparison with silicon, chromite, mullite, and a fused bauxite sand. Silica sand presents the higher thermospation, as we know. Chromite and fused bauxite sand have low thermospation, but above castball and mullite sands. The low thermospation of castball provide for the casting excellent surface finish, high dimensional stability, and eliminating of hot tear defects. Okay. Here we have another example. Okay, when castball is added to silica sand mix, the total thermospation of the mixes is reduced. The thermospation results obtained of silica sand among castball show it. Okay. Additionally, the surface finish of the casting tryouts has proved it. The amount of the veining is reduced as the amount of castball in the silica sand mix is increased. Okay, we can see the results when we add castball into a mix with silica sand. We can improve the surface finish of the castings. Here, this example is with iron casting. We can see the thermospation, right, is reducing as the veining defects and penetration defect. Next. We have here real examples, okay, of improvements in the surface finish of the casting parts. We can see casting finish surface of a cylinder head. This area is in water jacket. And 25% of castball can provide similar finish casting to 25 mullite sand, 30% of chromite, or 25% of a fused mullite. This example of the castball, okay, in a real case, in cylinder heads, we can see here the difference of the results. Castball provide a very good surface finish and very, very comparable with the other types of ceramic or natural sands with low thermospation. Okay. Another castball application case. Here we have a piece of manganese steel alloy. Castball replace a chromite sand as facing mold. Okay. We have the area with castball is very clear without burning. And the other parts, the external parts, external area, they use chromite sand, and with the finished area is rough, right? They replace chromite in an internal area, and the result was very, very good. Talking about dimensional stability, this is other characteristics very important in a foundry, especially for cylinder heads and cylinder blocks. Castball provides high dimensional stability for the castings due to its low thermospation. Okay. In this case, we have results of the master thesis study that indicate just 7% of castball mixed with silica can replace a mix of 100% of chromite or a 65% of mullite and maintain the same dimension. Okay, this graph shows the deformation. Okay, the correlation with the correlation with deformation with thermospation. We have different mixes, different compositions, silica sand with chromite in the first graph. In the central graph, we have silica sand mixed with Castball. And the last graph, we have silica sand mixed with Mullite. Okay, and the results are the deformation of the casting in millimeters. They use a specimen to test and validate this behavior. And a 7% of Castball, the result, the core deformation, or the result of the core deformation, yes, is very similar to 100% of chromite. We can put another composition and have a reduction cost, okay? And can replace to a 65% of Mullite and maintain the same dimension results. In real case, okay, in the first case here, we are showing for you an engine block. Okay, this project considers Mullite sand and Castball. And then regarding to the dimensional stability, surface finish, core density, Castball and Mullite sand present similar results. And results better than silica sand mixed with iron oxide. It's very common to use this kind of composition in shell process, okay? However, Castball present best results than ceramics regarding binding content reduction and broken core scrap, okay? We can see here in these graphics below, okay? Broken cores with Castball, this problem we're solving, okay, we're solving. And about the binder, the last graphic, we can reduce the binder content when we replace Mullite sand by Castball. We can reduce a lot the binding content in shell process in this case. And the last case that we are show for you, Castball replaced zircon sand. This piece is a head of nose tip, a copper metal, okay, in this case. And then with Castball, the casting presents high dimensional stability, excellent surface finish, and a greater permeability. In other words, the piece produced with Castball presents similar results than the pieces produced with zircon, but at lower cost, okay? About thermal conductivity, it's another characteristic, it's very important. Castball presents low thermal conductivity, similar to fused bauxite, silica, and Mullite. And as we know, chromite sand, like zircon too, presents higher thermal conductivity, okay? The thermal conductivity impacts in the mold cooling rate and the casting are affected too, okay? With this characteristic, the low thermal conductivity, we can solve some problems, okay? The kind of problems that we can solve is misroom, hood shoots, especially in tinier sections. Unwanted phases relate with high solidification rates. Shrinkage for situations where there are difficulties to fit, and hot tears and hot cracking, okay? This is a type of defects that we can solve with types of sand like Castball, okay? And when we use a chromite sand, We can solve other types of defects, but this kind of defects, normally we start to have problems when we use acrylonite. Next. Okay. Here we have the results of the starting temperature of sintering in the foundry sands. Okay. The results are organized from the highest temperatures to the lowest. Here we have silica sand and Castball. They presented the highest initial sintering temperatures, while sands such as fused bauxite and chromite had the lowest initial sintering temperatures. Okay, it's very important when we think in penetration defects, okay, and in the durability of the sands. We can change. Okay. Now we will talking about durability. We did a study about the attrition resistance of foundry sands based on studies carried out by American University from Michigan, okay, and from Iowa too. These universities have been studying a lot about the durability of the sands during the recovering process. We did a similar studies here in Brazil and published this study last year in a Brazilian Congress. Okay, we chosen silica sand, chromite, Castball, mullite, and a sinterized bauxite sand, an alternative sinterized bauxite sand to do this study and compare the results. Next. Okay, well, we measured the sand attrition resistance with a ball mill according to the ANSI procedures. The test consists of a cylinder that rotates with the steel balls together with the sand sample. Okay, everything is controlled and standardized. The breakdown of the sand samples was measured by comparing the change in GNF after the attrition. We did this study in different attrition times, in 1, 3, 5, 7, and 10 minutes. Here we have the results for silica, chromite, and Castball. Okay, we have here 6 curves, okay, 6 particle size distributions. The first curve, and yellow curve, is as receive the material, okay, and then we start to do the test 1 minute, 3, 5, 7, and 10 minutes, and we can see the change in a curves. The curve start to shift to the right, indicating that the sand become finer. Okay, the grains start to break and reduce and change the sand distribution, and we have a lot of formation of the fines. We can see here in this graphic the behavior of the silica sand, the chromite, and Castball. Castball maintain the results, maintain the particle size distribution. It's very, very similar after the attrition. This is, it's as a result, indicate that the Castball present a high durability, higher than chromite and silica sand. The next. Now we compare Castball with other types of ceramic sands as mullite, and a bauxite sinterized alternative. And we conclude that ceramic sands presents higher durability than natural sands, such as silica and chromite, but Castball present the best results, okay? And the results is associated with the corindon phase that we saw at the beginning. Castball present a lot of, the main phase is corindon. This type of phase is very present a very it's difficult to break this kind of material. Okay, it's different with mullite and silicon chromite. The phase presenting this type of sands is easier to break. We carry out some practical tests, okay, to validate the laboratory tests. In this case, we carry out the practical test in a gray cast iron foundry. And during the test, Castball was recovered by mechanical process. And the sand distribution after 3 cycles was measured, okay? We can see the results. Castball maintained its sand distribution curve and GNF, while the silica sand become finer, as seen in the results obtained in laboratory with the ball mill. And then we can conclude that the attrition test in laboratory show a good correlation with a practical results in a foundry, okay? And Castball presents the high durability in laboratory in a practical too. During the recovering process of Castball in silica sand in this specific foundry, we made some videos to compare the dust generation, okay? We are showing the pictures. We have the video, but we have problem to show now. And then we take the pictures from these videos. Okay, the test was performed with the dust collector uninstalled to visually assess the dust generation. We can see the difference. With silica sand, we have a lot of dust generation. And with Castball, the dust generation are very low in comparison with silica. Okay. Okay. Well, we talk about now a little bit about compatibility with the binders. Okay. Castball was tested with many foundries, and we have learning more and more. We put here some suggestions that we can see with our customers. And for example, for furan resin, no bake process, Castball is more suitable when we use a fast medium cure rate. Okay. With phenolic uretanic, no bake too, Castball, we suggest low medium cure rate. It's better when we use this type of resin and catalyst. The behavior is better, okay? The results are better when we use these types of resins. And then we have here a suggestion for each process: cold box, hot box, shell process, solid silicate. Castball is very sweet for any different process. We put some results. Okay. Just a minute. I need to put English. We have here some results with furan resin. We can see here in this first example, okay, mixtures of Castball and silica sand with a typical resin using in Turkey. With Castball sand, the resistance increase slower, okay? After 1 hour, the resistance of the Castball mixture is lower than the silica sand, but after 2 hours, the mixtures with Castball reached a great strength. This is a behavior that the difference between Castball and silica sand for this type of resin. And the last example, okay, we are showing here the Castball with cold box resin. The mixtures has, here we can see Castball and silica, right? With 2 types of cold box resin. And the results are different too, okay? In the first resin, we have a little difference between Castball and silica sand in immediate resistance. And then with the time, Castball reached the same resistance to silica sand. In the other type of resin, we have a similar behavior, Castball and silica sand.
Diferente.
Okay. Here we have the types of process that we are using Castball. Okay. We have a key here, cold box, Furanic Retanic no-bake, shell, alkydic resin, ester alkaline, inorganic, and lost phone. And we are developed, sorry, we can return, please, Kumai.
It's back.
Okay, thank you. We are developed Castball in different process, in alkaline no-bake process in Furan, in water glass silicate in 3D printing, and in green sand too. We have study for 3D printing already and reading, and for green sand too. And in this slide, we can see the types of metal. Castball is an inert ceramic sand. We don't have problems with the different metals that we have. Now, our customers are using Castball in cast iron, and many times, many alloys of steel, okay, aluminum, bronze, and many types of metals. We don't have problems with this with the penetration, with type of interaction with these metals, okay? And we put here a score, a ranking with different sands using the foundries and compare with Castball, okay? We have here Castball, Mullite, a fuse ceramic sand, fuse bauxite sand, a chromite, and a silica, okay? And different properties, mechanical and thermal properties, physical and chemical properties. In attrition resistance, Castball presents the best result, as we can see, very high resistance. We have high thermal durability too, low thermospation, and low thermal conductivity. Okay. About the physical and chemical properties, we have high permeability, high sand flowability, non-crystalline silica, and Castball presents magnet properties. Okay, we can separate Castball from silica or from mullite sand, for example, using a magnets equipment after recovering the sands. We can separate and use again the material, and of course, with type of practical, we can reduce the costs. Okay. And now, to finish, we have here a summarize of Castball sand potassium reduction costs. Okay, we can save in cost process. We've reduced scrap scores. We have opportunities for reduction of coating, and sometimes we can eliminate the coating for some process. It's possible. We can reduction of steel shot consumption, blasting times, manual operator times, casting heel works, and we have opportunities to eliminate the heat treatment on castings. We can reduction too of environment costs, like sand disposal, transportation, and we have opportunities to reduction the safety equipment and health costs too. We can increase in competitiveness. Okay. With Castball, it's possible to achieve production stability, reduction the core weight when we replace chromite. In this case, we can increase the productivity and quality too. Okay, one point very important, it's a manufacturing of the parts with complex geometries and high dimensional accuracy. Okay, Castball can give you this opportunity to manufacture this type of parts. And the last is a reduction of environment and health problems. Okay, Castball is non-silica crystalline. Okay, it's free silica crystalline. Reduction of the sand dispersion, reduction of the dust generation, as we see, and we can reduction ergonomic problems in finish area. Okay, when we start to reduce the manual operating times or operations with Castball, because they improve the quality, the surface quality, we can see, we can put attention in ergonomic problems. Sometimes we have this kind of problems in our foundry, and Castball can help in some cases too. Okay. Well, it's that. I appreciate your time and this invitation. Okay. We are open.
Thank you.
To the questions.
Elaine. Thank you, Elaine. That was a good summary. One slide before, that was a good summary of benefits and so on. Only one info is missing: contact info. So the colleagues in Turkey, are they going to contact with LMA for their demands or directly to you? What is?
Yes, for all the demands, they can contact LMA. LMA is our distributor in Turkey. So everything related to Castball, the customers can contact Ms. Beste.
So Beste Yüksel will be their contact in Turkey for further questions and the info then.
Correct.
Good. Now I'm waiting for our colleagues to fill the form for their, let me say, questions into chat box. But until that point, I have got few questions, very simple questions, Elaine, don't worry, about the green sand trials. Which kind of tests are you conducting to use Castball in green sand process?
What? Sorry?
You said that you have shown us a comparison of Castball already in use, and the second row was about your trials, your efforts to use Castball in the processes. One of the process there was green sand. So
Yes.
which type of tests are you conducting on green sand process to use Castball?
Como é? Você entendeu?
Quer saber o que você está fazendo com relação à areia verde? Quais são os testes?
Okay. We are doing tests in Michigan University and here in Brazil too, okay, just in laboratory, okay, Mr. Saley. We did some tests, some mix Castball with sodium, calcium, bentonites, activate, and natural. The three types of bentonites that we can use, okay, in a green sand. We test according AFS procedures and some some dynamics procedures from Michigan University. We tested too. Properties like green, compressive, weight, tension, resistance, the typical properties just in laboratory. And we did some tryouts too, testing tryouts, but in laboratory until now, okay? We published an article last year, in this year, and next year we will publish a new study about Castball in comparison with silica and chromite. Okay?
Thank you. Şimdi arkadaşlar sorularınızı bekliyorum. Aşağıdaki sohbet kutucuğuna yazmanızı. Ama siz sorularınızı yazana kadar ben kısa bir özet yapayım. Bu bir sentetik kum değil, yapay kum değil. Tam tersine doğadan çıkartılan değişik minerallerin harmanlanması, bir takım arka arkaya işlemlerden geçirilmesi sonrası elde edilen bir kum katkı malzemesi. Ama kalıp kumuna mı, maça kumuna mı, nerede kullanacağımızı tavsiye edecekleri oranları şimdi soracağız kendilerine. Ama ben bu soruların sizlerden gelmesini bekliyorum. Şimdi bu sunumun güzel yanı özelliklerden giderek problemlere nasıl çözümler bulunabileceğine ilişkin güzel örnekler paylaşıldı. Bu örnekleri belki problemimize göre test etmemiz gerekir. Hangi kum karışımından hangi problemleri çözebileceğimizin ipuçlarını veriyor. Önemli ipuçlarını veriyor. Sunuşa geç katılanlar için söyleyeyim tekrar. Arzu edenler bu şu anda ekranda izlediğiniz Türkçe sunumu veya onun İngilizcesini arzu ettiğiniz anda LMA'dan talep edebilirsiniz. Onlar paylaşmaya hazırlar. Bunu kendilerine sorduk. Şimdi sorularınızı bekliyorum. Sizin sorularınız gelene kadar ben bir iki soru daha soracağım. Elaine, are you able to read the question there? Is there any rough comparison between cost of this sand and other sands?
Is there any rough comparison between costs?
Click chat box.
Okay.
Mr. Say, if they compare to silica sand, of course, the cost is higher because it's a ceramic sand, but we can say it's way cheaper than ceramides, for example.
So you are comparing your cost with ceramides?
Yes, we can compare to ceramides, which is also a ceramic sand. If the comparison with silica, of course, is much more expensive. But comparing to ceramides, we can say it's very competitive and even lower than ceramides.
Okay. Mr. Nain is raising his hand, but in this program, we are not able to give you right to speak, to ask your questions. Now, if you write down on the chat box, we will be able to handle your question. Okay. Let us wait for the question of Mr. Lene. So you have given us, Elaine, a few formulas about the mixture ratios. Those ratios are using 100% Castball, 100% silica, and in between, different ranges. So for a good sand mixture for cold box, what is the best percentage? Is it to 75% silica sand, 25% Castball, or vice versa? What is your preference?
Okay. Well, depends of the situation, right, Mr. Seifi? But normally in automotive industry, I think it's a good point to give you the best composition, right? Or the most common composition. 30% to 50%, okay? Between this range, normally Castball provides a very good result for veining, okay? And penetration. Some case for penetration, we need to increase the quantity, okay? And some foundries use 100% of Castball to solve the problems that they have in specific parts, okay? But in January, 30 to 50%, to 30 to 50% of Castball. This is the composition.
Okay, thank you, thank you. A question coming from Five Nene saying that Michigan University, are they able to do the magnetism strength of the Castball?
They don't have. Iowa have this possibility, okay, the university from Iowa, okay. Well, normally they use this type of equipment after the thermal recovering, okay, or mechanical recovery, because we have the grains, desegregate the grains, and then we can separate, okay? If before the recovered sand, it's difficult to separate the grains because they are together sometimes with silica or mullite sand. Okay, I don't know if I respond.
Okay, let
Are
us
you
wait
able to
response
be before
from
and after? Yes, they are able, okay?
Okay. So another question is coming from Gizem Moore. She's asking that if we mix Castball to green sand process, by the process later on, how will we recognize the percentage of Castball remaining in the green sand? After casting some metal into green sand.
Okay. Well, in this case, mix with silica sand, right?
Yes.
Probably. Okay. You can recognize the amount of the Castball with chemical analysis, okay, or by magnetic test. We can buy like a imã. I don't know imã in English. Do you know, Peter? Imã in English?
The magnet. Magnets.
Magnet.
Magnet?
Hand
Okay.
magnet, yeah.
Okay, you can buy a magnet and doing this in laboratory. It's possible, it's very common to do that. Okay, I don't know if I answered the question. I hope so.
Hopefully. Okay. From Mr. Nene coming another question. For the green sand test, what we did internally to check the effect of Castball to our green sand was to add some Castball into a silica sand mix with high sodium and calcium bentonite, and did the typical green sand test. Was this the correct approach?
What we did
Actually, you
internally.
did not mention about
Elaine,
sodium and
just
calcium bentonites.
Elaine, so you know, Piu Nene is the engineer from the factory in South Africa that we are testing Castball.
Okay. Okay, thank you. Let me check again the question. What we did internally to check the effect of Castball to our green sand was to add some Castball into silica sand mix. Okay, in this case, he's mentioned when they use a Castball in a core, okay, and then the cores, the sand start to into the mold sand, right? This is the question, right? I think.
Seems so.
Yeah. Okay. Look, big foundries, okay, as I can mention these foundries, okay, like Tupi, like other types, Texit, and whatever, more than they use a lot of Castball in cores with silica sand, okay, and they have a green sand process for molding. The sand introduced into the green sand, okay, the Castball, and normally they don't control, okay? Normally they don't control if have some problems or effect, okay? Because we don't have many years they are using, and the effect of the Castball into the green sand system, it's normal, okay? We don't have see something that we can say it's because the Castball. Doesn't happen, okay? What we can do if you have some concern is just checking the chemical composition of the sand. You can control every month and see how many Castball you have, and just to have this control, okay? But Castball is very adequate for green sand. No problem. We have found with Castball.
Just a moment. Arkadaşlar kısa bir açıklama getireyim. Sunumda geçmedi ama bir soru geldi. Sodyum ve kalsiyum bentonitleri ilavesiyle testler tekrarlandığında bizim normal döküm kumumuzda, sentetik döküm kumumuzda ne değişir diye bu Castball ilavesinin değişkenlik göstermeyeceğini, sodyum veya kalsiyum bazlı aktive edilmiş bentonitlerin kullanımının herhangi bir değişikliğe yol açmayacağını söyledi kendisi. Soru kendi organizasyonlarından gelmişti. Another question is coming from Cem Kasapoğlu. Does it have abrasive properties like chromite sand? Chromite sand causes wear in core shooting machine chambers.
Mm-hmm. Yes, this person is right. Okay, chromite is very abrasive and cause wear in tubulations and etc. Okay, the difference between the two materials is the shape of the grain. The wear of the materials are causing by the resistance of the material, of course, right? But the shape of the grain is one of the most important. In this case, chromite is angular shape, okay, the grains. And then this type of shape promotes the wear more than castball because castball is rounded. This kind of shape doesn't avoid the wearing. This is the point. And then the abrasive behavior of the castball in practical is better. Even so, the castball present more durability. Okay.
Okay. Thank you. Thank you. Peter, now I will ask you the question. What is the discussion between Mr. Nene and yourself about the magnetic properties of Castball? Is it about the tests? Fikri, Peter'in şeyini
his microphone is mute, yeah.
Yeah. Fikri Bey, Peter'in şeyini açalım. Mikrofonunu açalım. Yeah, now you can.
Yeah, now I can.
Answer.
Thank you. It's about the green sand test.
Yes. It's about the green sand test, and you said that you are able to do the tests
No, I
at
mentioned
Michigan
that the
University.
tests that we done at Michigan were comparing 100% Castball versus 100% chromite versus 100% silica sand. Was no mixture between Castball and silica or Castball with any other type of sand.
Mm-hmm. Mm-hmm. So, Elaine, it seems that there isn't any more question about our Turkish participants. It seems everything is clear, well enough explained, and I informed them in Turkish that we are able, or LMA in Turkey is able to share the presentation either in English or in Turkish. So, thank you
Mr.
for your... Yes, please.
I just would like to mention that we can also share the studies we have on green sand with Castball in English. So if the participants are interested, we can also share this presentation.
Okay. Thank you very much. Thank you.
You're welcome.
Thanks
Thank
to
you.
all of you for sharing your valuable info. Okay. Hoping to see you at some other platforms. Bye-bye then.
For sure. Teşekkürler.
Thank you.
Thank you for